Hello, I would just like to make a video today about this plugin. It's the Async Blueprints extension by LazyPanda07. This enables multi-threading through blueprints, which without a plugin, I do not believe is doable. So I'm making this video just because there's a bit of a lack of information on how this plugin actually works. So we're given three videos. Within the first video is a link to the documentation, the GitHub page. And in here, there's still not a ton of information. It's just kind of a classic GitHub page. It can be a little bit hard to follow until you know what you're doing. So I would just like to show how to use it. So if we come into a project within the blueprint class, we just have to search async, and we're given three different types of tasks: a short, long, and infinite. The difference between short and long, I am not too certain. From what I can tell, right here it says is you should be using a thread pool, and a long task will just use a separate thread entirely. And then an infinite task will just continuously run. It's infinite. So this is the life cycle on how they're supposed to go. So if you are going to use your short task, you should have some form of a queue. First you have to create a thread pool. I'll show what that is, and probably have some form of a queue to ensure that there is no overlap, and then execute it. A long task is just started and then executed, and an infinite task is just started and then needs to be stopped later on. Otherwise, it can run into some issues even with you having ended your project. My own personal experience, my task should probably be a long. I have found some bugs where I can just explain that later. So we're just going to create a short task. I'll just name it practice. And with opening it, we're prompted with nothing. There is just an empty blueprint. However, there is an execute and an initialization event override. And what these are is, it's in the name. It's an execute and initialize. So an initialize is still going to run on a game thread. So any type of information you need can be different stuff like getting from actors, or for me personally, I needed to set a seed, a random seed. The random functions don't work in an async. I'm not totally sure why, but yeah, so there are a few things you might need to initialize before you execute. I'm just going to show mine as an example from here on out. So, okay, let's hop into here. All right, so this is my own little function. I just call it run async. And the first thing I do is create a thread pool. I mentioned this earlier. I found some issues where if you don't actually create a thread pool, because it's a short task, there will be times where your task will just not run. It'll just seemingly fail, and it's because it's not having an actual thread that it's running on. If you're unsure what a thread is, it's just a CPU thread. You can see them within a tracer. A tracer is just found down here. I can't remember if you have to enable this in the settings. You might need to, but if you just start tracing, if it doesn't open anything, you can just open a live session, and we can start to view the different threads. Surely it'll open. Yep, there it goes. Kind of got to scroll out, pull it over. There we go. Sometimes it's a little weird. Take a second. Okay. All tracks, pop it in here. This is the game thread. This is where everything is run without multi-threading, and then you have background workers, which is where things normally would run with the async tasks. But as I mentioned, creating a thread pool will ensure that you have a place for it to run. And this is where we see this. I've now created a thread pool. It's called the WFC thread pool number 2. So that's what that is. And that ensures that we actually have a place to run I think specifically the short tasks. Mine probably should not be a short task. There's quite a lot of information and math that goes on, but it still works. So we'll take it right now. All right. Once you actually have a thread pool, we're going to want to make the task run. So if we just search async, we can see, scroll down, we can see the different threading async nodes. And we've got a create and run, different types. This is for stateful and stateless. From what I understand, this just has to do with different forms of caching. I just go stateful and it works, so we'll take it for now, right? And here's also the create thread pool as well as the destroy thread pool. I will go over the destroy in a second, and then you just have separate from create and run, you just have run, and then continuing down, we have just create. Now, you can use create and run, and this is just self-contains everything. What I have up here is a create, and then you pass it to you have to pass it to a variable, else it can get garbage collected in memory, and then run. And this allows for me to pass in variables. This cannot have variables passed in. You would just come in here, you would select your task, practice for example, and then all you can do is have the callback, which once the task is finished, it will run the callback, and that's just creating an event, and that's it. If you do this actual create task, we then have access to the non-accessible variables. See if I come in here, there's nothing. We could try to refresh it, still nothing. This is useful because I found in the initialization, it'll run every time you run a task. And I have information that only needs to be run once ever, and that just needs to be passed in, or things that change outside of what would happen in an actual task that also needs to be passed in and referenced. And I prefer to not try to cast in here and find those things and run it every time. It's just a bit simpler. And the way that you pass in things, you just have to hop in here, click on your variable, make sure that it's checked with instance editable and expose on spawn. And then should it not show up, just hit that refresh node and it should then show up. This allows you, once again, like I said, to pass in information. And then you just have to run the stateful or stateless, whatever you want to do, and call it back to a function. I created one called post async. In here, I'm going to immediately, you can ignore all of this. All that matters, I'm just going to destroy the thread pool. This is probably unnecessary if you're going to be continuously using it. I'm just going to be a little safe. I've noticed a few potential issues, but a good validity check on the actual task. And then we're going to cast to our task, which will then allow us to access whatever information we need to pull out of the finished task. I run another validity check. It's kind of redundant, but I had a bunch of issues where things weren't working, so now we're just going to play it safe, right? Then obviously we can set it as a variable, local or just global, and from there we can start to pull out information, pull out whatever math or whatever you needed to run. And that, oh yeah, here I'll show. I do like this. If you set a string, you can just current thread. In the actual execute, we can get current thread name. This is part of the async library. Append it, and it will show where, sorry, that's kind of messy. All right, it's gonna just keep doing that. We'll ignore that. It'll show the thread. Current thread, WFC thread pool 2. If I didn't have my own thread pool, it would just show whatever background worker referencing the background workers it was running on. So for me, I have 2 through 13. But yeah, and the only other thing that needs to be done is either in an actor or the game mode. you need to make sure to put stop tasks, especially if you're dealing with infinite tasks. It's still good practice to probably have. If you don't have this for infinite tasks, from what I understand, the task will just not end, despite ending the project and even closing Unreal. So it can cause a lot of memory usage and problems. And then I just have another destroy thread pool just to be careful. And yeah, that's about it for this plugin. It works quite well. And oh, that's right. Within the actual execute, remember this is on a separate thread. The game thread where things are normally run is how you would deal with actors and getting references to actors, or getting, what is it? Yeah, getting all actors of class. So you can't run any form of a spawn or a get within the execute, because these need to be run on the game thread. So if you want to do that within whatever logic you're running, you would need to make sure to run on game thread and then have that delegate as an event, and then run whatever spawning of actors you need. Otherwise, it just won't work. And yeah, that should be about it. There can be a few little things that won't work. I found random numbers don't generate, so you have to pass those in. But yeah, that's about it. If you have any questions or anything, feel free to ask. This is a very, very useful plugin. So I hope you can figure it out and enjoy it.